Hey everybody. I thought this was a really insightful paper and I figure it will likely get overlooked by a lot of people, so I figured why not make a video on it. The paper is called OC Atari Object-Centric Atari 2600 Reinforcement Learning Environments. And it's put out by a group of researchers in Germany from multiple research institutions. And so just going with the abstract, essentially when it comes to machine learning and video games, there's really two different approaches that you can utilize for how the agent actually performs in the game and what it can do. One of those approaches is called object-centric representations, which essentially is feeding the data like directly into the agent so that it doesn't actually see what's going on in the video game. And then the second one is visualizing, like actually like giving the AI agent eyes to see what's going on within the game. And then so this paper is all around methodologies with that first method. So the AI agents in this instance and in the instance of this paper can't actually see what's going on in the game, but rather their approach is to feed the AI agent the data that it needs to operate, and it's essentially the states of the game. And the interesting thing, they release all of the code here on on GitHub for anyone that would need it and to access it. Their code is good with 57 different Atari games, and then so it's only good with Atari games. But the interesting thing, and they highlight it throughout the paper, is that the way that Atari games work is that they store a lot of the game information within the RAM of the program itself, and then so their program is essentially utilizing the RAM of Atari games to feed the model the information that it needs with regards towards game state, etc. And then the interesting thing with that is that you can, if you do like raw manipulations and then you manipulate the RAM within the game, you can change essentially the priorities that the agent utilizes, change the game state entirely, essentially by manipulating the RAM of Atari games. So I think that's also another interesting thing to highlight within this paper. But I think the first thing to highlight with the paper itself is in this diagram, like this chart they show here, what we're looking at is the number of, it's an interesting diagram that they put out, but it's the number of publications related specifically to either Atari, it's like Atari and reinforcement learning, object-centric reinforcement learning, or object-centric object-centric approaches plus Atari. And then what you can see through this graph that they show is that while there are some publications and a lot of publications around Atari and reinforcement learning, and those publications have gone up year over year. I think it's interesting to highlight though too that the correlation between the years here, that you see like this stark around 2017, 2018, it just goes off the charts. And then that's to me like the introduction of the transformer model right around that same period of time. And then so I think you see a lot more attention being paid right around that time, and then it just shoots up. And so to me that's why. But going back to the original thought, which is that what they're trying to highlight within this paper is that the object-centric approach and papers around utilizing object-centric approaches with Atari learning or with video game learning, that specifically is a subject that hasn't been researched a lot. And then so that's why it's curious to me every time I see a paper on the subject specifically. But so diving deeper into the analysis, essentially what they do on a very basic level is it's really simple, is that they essentially give the agent access to the RAM within the game, but then they also give it a dictionary for knowing what to utilize, how to utilize the information that it's taking in. And then so that's kind of like the second part of, like that's the main part of OC Atari itself, what they're calling OC Atari. Is that kind of like dictionary, that framework for understanding its environment. And then so its environment in this instance is Atari 2600 games. And then I think that like that's the significant part of this to me, and more, all of the research is showing that why video games are good training grounds overall for AI models and for agents is that the AI agents is that they can create frameworks very easily to understand within games, and within simulated environments. And I think that that's, to me, a huge gap. The one of the missing gaps that we have currently right now with AI is giving AI the ability and the knowledge to, one, understand what a framework is, and then two, utilize that framework within its environments, and then three, understand like why that's actually productive to do. And then I think we're getting, as we develop and we research more and more, it seems to me more and more that it comes back to the best technology that we have around that specifically isn't like feeding the model a whole bunch of data on this subject, on this topic. It's letting it explore in simulated environments like video game environments, and then giving it like dictionaries to be able to build its own framework off of those things. And so that's essentially what this does. And then so throughout the rest of the paper, essentially they go through the different environments, all of the different training, all of the games that are utilized and that you can utilize the framework for. They're all Atari games. But essentially anyone, if you want to download and hook up a AI agent and then have it play through games, you can do so here. And then they have also their benchmarks. And then so pretty much all of the major Atari games that I would think of, like Pong, Qbert, tennis. I do notice that it doesn't do Pitfall. Yeah, I see Pitfall isn't on the list. So there are some Atari games that the agent won't be able to handle, or that this framework won't be able to handle. The other thing that they go into is essentially how exactly the process for manipulating the RAM and RAM manipulation. So if you're interested in training Atari games or training AI models on Atari games, this paper gives you really good highlights and information for doing so. I think the last thing to highlight here that I want to talk about within this paper very specifically is they talk about it really at towards the very end of the paper, which is like essentially other applications of this. And what they mention is that what they specifically did not do in their testing is that they did not couple this with vision learning. And I think that, to me, that's the next step, and that's the next paper that I'm waiting for, and I hope that more and more people get interested in testing AI in simulated environments, because I do honestly really think that this type of training is going to be more successful in the end than just flat out data training. I don't think that anything will replace like flat out data training itself, but I think that putting AI agents into simulated environments and training them based off of those simulated environments is going to augment that training. And I think we'll find that it's kind of a key fundamental resource towards getting AI towards that next step, because I think that it's the best way to get AI agents to develop a actual framework, and it's most real world to how people and I think like how life would go about like handling a task like this. Like, for example, if the task is to play a Atari 2600 game, I think that it's a mixture of both visual data, so the other component that we haven't been talking about with when it comes towards agents and training them on these games, where you actually give them the actual, like, here's what's going on in the screen. But then if you couple it with here's the RAM information, which is essentially to them like here's like your life, your score, the opponent's position, your position, those types of details that essentially you would be we would probably be going on through those in our subconscious. So essentially building out more or less a subconscious for AI models, I think is the best approach forward within that. And then I think that the best approach that we have to do that is within video games in simulated environments. So to me, I think the next two steps forward as far as this are one, to couple these approaches, the approach, this object-based approach that we're talking about within this paper, plus like a visual-based approach. And I think we'll see exponential off the growth charts, which is actually, it's something that hasn't been done, so it's something that someone could easily do. And then the second thing I think that needs to be done on top of that is more research into actually training models on video games themselves. So I think that also implies that some video games would have to be reworked, or perhaps there are video games that would have to be looked at that would be very specifically more applicable and more interesting or more useful to training AI models than typical video games. But I think that those video games do exist, and I think if we combine those things and we research through, then we're going to find that video game learning is going to be just as important as data learning moving forward, or has the potential to be, which is why I'm always so interested in simulated environments and these papers around them. So if you like this type of content, please like and subscribe. Thank you very much.